mens vi lige venter på at gå live. Yes, welcome to this Faglig Fredag at Lund&Bendsen. We are pleased to see so many here in the room, and also welcome to all our attendees at YouTube. Our first speaker is Ejvind, who will talk about data platforms and Snowflake, a subject I'm very new to, so I'm really looking forward to gain some more insights into this. So, Ejvind, the mic is yours.
Thank you very much. Thank you very much, everyone. A lot of people. I'm really. Before I switch to the next one, I can say that I have 45 minutes. My plan is it's around 30 minutes with slides and 15 minutes with a demo, and I would like to keep that sequence. So therefore, questions would be preferred at the end, because otherwise I might not be able to make it. Okay. A little bit about myself, and while you read that, then I would like to know something about. I'd like to collect some data for you guys, and some of the things is there anyone of you who are working in a company who actually put data first, who says that data is the basic source for revenue, who has that as a defined strategy? Anyone? One there? Very few. Interesting. Next thing. Technical thing. It's related to my presentation. How many of you have been using a SQL Server DAG pack functionality? Used it in real life? 2? Okay. 3? Yes? How many of you have been using an automated release pipeline? Of course you've been using it, but have you been using it for a data solution? 2 people? 3 people? 4? Yeah? Okay. It's just for me to know where are we in this, because I'm going to touch upon some of these things later on. So in my presentation, I'll start fairly high level, which might be a little bit abstract for you, but I'll end up deep down with tech stuff. Okay? This here is a drawing you won't find in any teaching book. You will find it absolutely nowhere except on my website, because this is the way I perceive the world. This is my idea. The first one is, I mean, what it's supposed to mean is, what is the challenges today for an ordinary enterprise? And what I see is that on the top you have external adaptation with the red one, so they can also follow me on YouTube. What do I mean by that? I mean, there's nothing new in that companies need to adapt to the competitive, to customer needs, whatever, blah, blah, blah. But what has happened lately is that you have the rise of the internet. The rise of the internet has had a consequence that you have a lot of sensor technology, which is cheap. You have connectivity across organizations, across the entire value chain. This means that you need to bring digital service into your product today. If you don't, then someone else will, and then you'll be history. This is the external adaptation of today. So what that means is that it puts a pressure. It puts a pressure on internal efficiency in the companies. Because now you need to work with data, you need to work with it very fast and very agile. And if you don't have the data or even have access to the data, someone like you who is working with front end, if you don't have access to them in an easy way, you cannot use them, you cannot utilize it, and therefore you cannot perform as a company. The last thing is the implementation. At the end of the day, all of this is slideware. If you don't have any code running, this is what make the car go. And today I'm only touching upon Snowflake. But Snowflake is just one piece among many pieces. It's just one alternative among, you mentioned Databricks. I mean, also fine product. I just picked up Snowflake today. But there are many other components. Due to the time that I have, it's only Snowflake that I can talk about today. Now I'll walk through these one by one. Start with the top one. This is the only slide I have on the external adaptation. I picked 3 examples: a US company, a European company, and a Danish company. If you take Boeing, they're producing aircraft, as we know. They're using digital twins, meaning that they produce an aircraft. There's a link when it comes out. This is for a military aircraft. They produce it in a digital way first. Everything, not only all the software that runs the plane, but also, some of you might know this concept of finite element calculations. They're doing all of this, so they simulate everything before they build a physical one. Booking.com, this might be something that interests you, Jesper. Jeppe, you might already know. So what they have, they're building a platform. They have a platform where they encourage to do experiment. What does that mean? It means that the people who are employed there, they can take a small portion of the clients, and then they can be offered an alternative website, alternative functionality. It could be people who search for hotels in a specific area. It could be people of a certain age. It could be male, female, whatever. And then they do A and B testing, and they have industrialized this. It's not just something that you can do. You can order a specific one, and then a specific experiment, and then you commit this, and then you do this, and then you get the response if it's actually working or not. This is a learning organization to a very high degree. There's a link to the article which is explaining this one. Booking.com is headquartered in the Netherlands. That's the European company. Kamstrup, you'll probably know them. I have one in my home. Many of you guys will have. It's a water metering. It's a very, really basic product. But what they actually can do is that based on all of these metering things, which are connected to a local antenna in the garden light on the street, that's the way it works for all of us. Based on these impulses, they are actually able to detect if some of the water pipes in the road have a leakage. And that piece, they are selling that to the water utilities suppliers. And people tell me that Kamstrup on the metering themselves, their margin on the metering themselves is very, very low. But on this one, this is where they actually make the money. This is a pure digital product. 3 examples where data is the source of the value creation. Then I picked some sensor examples. We had sensors before. Tesla this car is filled with these. So what you can do with this, and also car manufacturers, is that you can take this the sensor content, you can put it into a digital twin. And one of the examples that I've seen is that they have taken this from wherever it's running. It could be icy or whatever surface it's running on. They put it into a digital twin, and then they figure out if you continue with this one, then you will have an unpleasant ride, or the shock absorbers, they might have a shorter lifetime. So therefore, they use this to improve the product, and then they send out a fix, so to speak, right? This is some of the examples where the sensors go in. Saxo Bank, we have someone here today. They also have sensors. You can see exactly every single click on the platform, and you can use that to, enhance the features that are used a lot, and the features that are never used, then you can remove those. They could be examples of this. Trackman. It's a Danish company in Vedbæk. Do you know? Anyone knows Trackman? Yeah, a few. It's golf tracking equipment. It's pure data. It's advanced radar technology where you can track how, the speed of the ball and the rotation and all kinds of things. And one of these green things or this orange thing costs 200,000 DKK. So it's very advanced. It's all data. Veo, Danish company as well. Do you know anyone? 1, 2, 3. Veo is an advanced camera solution that you could put up on a soccer field. And what they can do is that they can track your kids, how many kilometers are they running, how many passes did they do, how many goals. They can make an automatic replay. The same as we see in the national TV things. One of these small things can do that for small clubs. They're selling it all over the world. It's also data. It goes via the cloud, so you need to have a subscription to see it. WAP is a sensor that you have around your wrist. It's a US company, US East Coast. And what they do is that they sense all kinds of things, very much like your Apple Watch, but it's much more sophisticated. They can sense your stress level. They can also sense recovery if you've done some exercising. And my neighbor, he actually tells me that if you take an extra bottle of beer, you can see that your recovery is slower. So you might not use that in the weekend. These are some examples of where data is the source of the value creation. Then I'll turn to the next one. This is the internal efficiency. This is here. I have some more in depth that I would like to talk about, because if you have all of these, where data is the core of the product, we see that everywhere. I mean, some of these examples were just a few. There are many more. You probably know them. It puts pressure on the internal organization for data, and this is what I'm going to touch upon. I've selected these 4, and there are actually many more subjects which I have excluded for today. The OODA loop. The OODA loop, it's back in the Korean War. We had the US fighting the enemy, and the enemy had MiG fighters, and this guy here, John Boyd, he couldn't understand why is it that we're winning. So every time one US flight was shut down, they shut down 9 MiGs. But the MiGs were faster, they climbed faster airspeed and everything. He couldn't understand why is it that we're winning here, even though we have equipment which is not so good. What he came up with was the OODA loop, where maybe it's difficult to see, but what it is that you observe, you orient, you decide, and you take action. And what he found out was that the faster you could do this, the more time you could do this. I mean, take action about, should it be offensive, should it be defensive, what should we do next? The faster you could pass through this OODA loop, the better. That was what actually made them win, even though they had equipment which was not so good. And this guy here is a professor from MIT. Included a full link to a training session there where he talks about this is used very much in business. And then you can say, why do I put emphasis on this one? We're talking about data here. Yeah, but data is different than an application, because in an application you push a button and something happens. What you want to do with data is that you want to grab it and you want to get some insight, you want to get some action, and you want to do something about it. And then you get some feedback, and then the curve continues. Does all of this make sense to you? This is why I'm putting emphasis on this one. And this has a direct connection to DevOps, which many of you have been working with. But it's not so easy. So 2 months back, Netflix, they posted this one. Netflix is a large organization with many specialists, really a lot of qualified people. But even these companies, they think that in order to gain insight, you need to have Superman skills. So they posted this one. So it's very obvious to everybody that it's not easy. There are many things that you need to deal with if you want to go through this OODA loop. And the reason why I put this is because the next slides I'm going to address how can you overcome some of these challenges. And that's the idea. Make sense? Okay. Okay, high performance teams. That's the next one. We all know this guy. He did very well. In 2002, he set out this API mandate with the 5 rules. How many of you know this? A few. He put in some restrictions about API and uses of API, how we should exchange data internally in the organization. In 2008, he came with a maybe a little bit more famous pizza rule. How many have you heard about this one? Yeah, this is much more famous. It's actually not so much related to how you should exchange data, but it's related to team size. At the end of the day, in 2020, I mean, and there are links for all of this. The Amazon, they have more than 125,000 deployments every single day. And why do I mention this? I mention this because a deployment is basically an OODA loop. You put in some new code, this code does something, you get a feedback, and then you can change your code accordingly. This is a small OODA loop. And what happens, we all know what happens, is that Amazon, they have been able to scale really a lot. People-wise, organizational-wise, they've been able to scale. And this is, if you ask me, I think it's the 2002 thing that's the most important one in that one. I've been employed in companies where we have struggled scaling people-wise. So, then we have this guy here. How many of you know Project Phoenix book? Hands up. Yeah, around half. We have Jin Kim here. He wrote, he was a co-author of Project Phoenix and also the DevOps handbook. Project Phoenix is, I can recommend both of them, really amazing books. So I took some of the key things in that he says is important. He has something he called the free flows, and this is about maturity of teams. The more mature, the higher up. So teams which maybe have a it's me who using the term maturity level. So if you're maybe not so mature, you produce some piece of code, you ship it, off you go, and nothing more. Then you have some other teams who says we're a little bit more interested in what's actually happening, and then they actively seek for feedback. Is it being used? We all know the Spotify. I mentioned the sensors in Saxo Bank. It's actually being used. What do you think about it? So this is what he calls principles of feedback. And then you have actually this one here, the principle of continuous learning. This is the one with booking.com. So, and Spotify, they're doing the same, where the team themselves, they try to experiment, try to figure out what can be done. And then you can argue, isn't this just some theoretical thing? No, it's not. It's not. I've been a manager in Saxo Bank, where I'm working with some of these gentlemen that are here today, and I had my team running mostly in the yellow one. It can be done. It can be done. This one, I only saw that in glimpses. It's very much people dependent. If you have the right people in your team, if you can succeed with the top one. But I mean, if you do it with this one, you get much more. You get better quality. You get more happy clients. All kinds of things. Actually seek feedback from it. And then you can say, well, this is ordinary application stuff. Can it actually be done with data solution? And yes, the answer is yes, it can be done. You can deploy many times also with a data solution. Very often, the data solution, they come very late in the DevOps because it's a problem, because then now we have the data, we have historical data, and you screw it up for all the other people if you remove a column, blah, blah, blah. All of these problems. But is there a solution to this? And yes, there's a solution to this. But that is why the data is normally, when we talk DevOps, normally people they don't look so much about data because it's very difficult. It's very difficult. It's much more easier with what you could call a stateless application. The technologies that can do this, I cannot, I don't have time to talk about these today. Today it's about Snowflake and other stuff. But it is possible. Then we have the next thing, DevOps shift left. How many of you have heard about DevOps? Yeah, of course, all have. We all know what this is. I mean, you come with a requirement specification the old way, and then half a year later you get something. When that time has passed by, then the requirement has changed. It's no longer needed. So the new way is that you have it in sprints, you deploy frequently, and you get feedback. This here is also the ODA loop. One more time. It's the same way of thinking, that you need to search for feedback so that you can all the time adjust to what you're doing. Then we have Andrew Jones. Andrew Jones is from UK. He started his own company yesterday. I gave a little bit of help to him last week. He's a really nice guy. He invented the term data contract, and he made this drawing about shift left. You've probably heard about shift left, but what it is, when we talk about data solutions, what you see in many places, in many organizations, is that a data team, they will try to extract the data from all kinds of systems, and those who are producing these, who have these systems, the domain owners, they don't know what happened. They don't know that this is going on. And the problem is that there are many challenges with this. One of the challenges is that if you just copy the raw data, then in these domain-specific, whether it's payment systems or whether it's other systems, then there are some logic inside these. Of course there is. And then what happens is that in a data universe, then you sometimes need to repeat that logic. But the guys who are responsible for the operational systems, they don't know that you have written a similar logic. So when they change it, they don't know that you need to change yours. That is why it's the effort is very high. A shift left approach is that those who are in a data analytics world, a shift left approach is that those who are responsible for the system, they kind of publish the data that you can subscribe to. Does it make sense? because then they are aware of what's being consumed. They can incorporate their own logic. So while I was working as a manager in a data team, I actually succeeded for some of these to come to this. It's not just a theoretical thing. Where I had a high success rate was actually the teams where there was very complex logic. And maybe this was because whenever we came and asked them for logic, then it took so long time for them to explain which logic I should replicate. Then they said, we'll just make it for you, then we'll publish it. And at the end of the day, then these teams, they then grabbed the ownership for the data that was exposed and consumed downstream, which was really good, because then whenever they changed something, then they also changed what was exposed accordingly without us knowing it. And this is why you can see the blue one, it's lower. It's at the end of the day, for the company as a whole, it's a much cheaper way. But I would say, out of 10 organizations that I've been seeing, they use the red one. They use the red one nearly everywhere. Data analytics, not my problem. I mean, I do payment, I do insurance, I do whatever. I do banking. So if you could change that attitude, there's a huge gain. Okay? And can it be done in data solutions? Yes, it can also be done in data solutions. Then we have this data mess. We have Samakdegani, as very hard to pronounce. She identified that data is important. She also identified that you very often have one central team. That central team becomes a bottleneck. So she worked with this. She needed to move away. She wanted to move away from this centralized analytical team. And what she did was then she defined this thing called data mesh. It's a concept where it's built around a data domain where you split it into domain boundaries. It could be sales, finance, central team. They should publish data as a product based on a self-service platform designed for the purpose and controlled by some federated governance. And one more time, you could say, isn't that just a theoretical thing? No, it's not. So I have actually implemented this for a couple of Danish companies, and of course I cannot tell because that's the way it is. Except I have one, because last year I was invited to a Snowflake conference, me and Oplev, to talk about what we have done with data mesh, because we have implemented things running. Me and a manager from Oplev pension company, and these slides that I show you here, that is these slides that were published on that conference. So this is official, so even though, of course, I cannot disclose what I'm doing with my customers because they are official, I can walk through them for you now. So what it is that we like to enable autonomy. That's the whole idea of this. So that get away from a central team that becomes a bottleneck. That you need to, I would like to have this and this and this, and then you can draw a number and pick your place in the line. So they did that by creating data infrastructure as a platform, a self-service platform, and these four here is supposed to symbolize 4 different teams that can work together and contribute. And on the top of this, you have global governance, open standards. So it can also be symbolized in this way, a little bit more detailed. So these ones in the middle, I call them swim lanes. This is supposed to be 2 domains, 2 of those in the middle that you see here all the way through. They have their own sources, they have their own raw data, they can make their own products, and they can actually publish them. These blue ones that you see in the middle, that's the secret source, where you can publish something that another team can subscribe to. And it's very basic. I mean, today you'd see HR department making an Excel sheet with a number of employees, send that mail to a finance department because they need to know this. It's really, really basic, but it can be done in a very, very automated way if you do it right. It doesn't have to be the large systems. At the bottom of this, you have someone who actually makes the platform that makes all this happening. I mean, you have storage and query engine, you have monitoring, you have all kinds of things. You have some governance, and especially the middle one is the important one. make sure that all of this can actually work together, especially the connections. So if I come with a date in one format and you come with a date in another format, well, it's not really flying, is it, right? So they will come with something that ensures that this one here can work in a seamless way. They will also come with something that makes you able to actually discover what happens. This is some of the Superman stuff. That is that you cannot discover it, you cannot see it, you don't know where to look. I'm a new employee. Here's 700 tables in the warehouse. Just start moving. I mean, this is not flying, right? So what they ended up with 9 months back is that they had two teams. The central team was just a node, you could say. They had the investment team. I've helped both of them. And then they have actuarial team and finance team coming on. And now there are 7 teams, and I help most of all of these teams. And they are working independently. And they grab information, they come with their own domain knowledge, and then some of them also publish for others to consume. Make sense? This is real life, it's not a book theory thing. The way it is made, the toolbox, it can be all the toolboxes, but we chose Snowflake as the data platform, Terraform for databases, schemas, grants, all of this, all kinds of things. We use dbt, Power BI, Streamlit. External sharing with a number of vendors. In this case, it's ServiceNow. Yeah. So far, so good. And then some of the things that I have added in first, and then I walked this through at home the other day. Then I could see I cannot keep up my time, so I had to remove them. But this here is some of the really important headlines that I think is also deserve some focus. Especially this one, data governance, Danish ownership outside IT, who's responsible for that the customer data is not working. I mean, call a developer XYZ, it's not his responsibility. It's also something with maturity of the customer, that you actually appoint someone in the organization to be responsible for the data. Who owns what? Who's responsible for it? Yeah. Implementation, the last one. Today it's only Snowflake that I can talk about. So Snowflake is 2 French guys in Silicon Valley, originally from Oracle, plus 50 years like me, very experienced. They worked with data for many years, and they have designed the engine in Oracle. And they decided in 2012 that they want to build something new. They resigned from Oracle, got some venture capital, and they built a new commercial, basically a SQL engine from scratch, designed for the cloud. So many SQL engines that has been coming by the last 25 years, but many of them, like Postgres and other, it's open source. This is a commercial one. It's designed for cloud with unlimited compute resources and unlimited storage. And why is that important? This is because all of us has been facing scalability problems with the SQL Server. I've been working with SQL Server for 20 years. So all of us has faced this. So they said, why do we have to live with that limitation? We have so many compute clusters. So why don't we design an engine that can utilize all of these compute clusters? So this is what they had in the background when they actually made the design. How can we utilize it? How can we utilize that we have unlimited storage? So they got the first customer on board in 2014. They were listed on the New York Stock Exchange 2019. They bought Streamlit, which is an open source thing. They bought that in 2022. It's highly popular in the US. And they said if we can buy it now, we can afford it now, later on we can't afford it. Streamlit is gradually picking up in Denmark. It's a Python-based, very easy to use front end. And then last year they released what they call Snowpark Python API, which means that you can write SQL towards your database, but you can also write something 100% identical to Spark directly to Snowflake. It's trying to address Databricks basically. So this is used in top Denmark, for price analysis. We have some people from Top Denmark here. They're using Snowflake for this. That's an example. Okay, what is the architecture behind it? Now it's 10 o'clock. Okay, time is moving. Yeah, kvarter tilbage. Yes. So, Teradata is like this. Microsoft Synapse is like this. Shared disk. Think about SAN. What are you doing if you have the largest box? You bought the largest box. It's not big enough. Then you go to some of these. Snowflake combines this. The both of best worlds. It is built up around completely separation of the storage and the compute, 100% separated, and this is what makes the scalability possible, actually. And then you have a service layer in the cloud, and one of those that are very important for me is actually this one here. When I first talked to Henrik Nielsen, Snowflake, the first Snowflake employee in Denmark, then I said, is this one ACID compliant? Because otherwise I don't want to talk to you. And then he said, if it was not ACID compliant, I wouldn't be hired by that company. So I mean, this here it's an engine that can scale really, really much, but still ACID compliant. How many know what ACID compliant means? Yeah, of course you know. So this is the basics are there already, right? I need to move on to a demo. So New York, they have City Bike. City Bike is a company where you can rent bikes, like here in Copenhagen, and they are offering the data for free. You can access them. They have scrambled some of the names, some of the credit cards, but the rest is free. So this is what I'm gonna build my demo on. Okay. Any questions before I move on?
Well, yeah.
Yeah. Sorry.
Thank you. Well, it's sort of a concern because I think that your approach. What? Okay. But underlying all of the stuff that you're talking about, isn't there a necessity to focus on a mature CI/CD setup from the get-go and also compliance by design?
Yeah.
Okay.
Yeah. Yes. Yes, there is. But I have 30 minutes. I have 30 minutes only. So you're completely right. Completely right. Release pipelines, HDDops could be one. There are many others. I mean, all you need to have all of this. You need to have Git, as the gentleman behind you. You need to have completely focus on. I mean, all of these processes around Git. And this is not for a developer. This is for everyone. This is really, really important. DevOps is also not for a developer. It's also a management issue. I mean, this is why Amazon went all the way. This is because from this very senior level, you have focused on these things. Many places where I come, they think this is some technical stuff. Let the devs run with that. It's not my business. Yes, it is your business. If you want to do it like Amazon, then it's your business. That is my claim.
So the problem is that the overhead cost of working to save over time, there's a huge upfront cost that most projects have a hard time finding in the beginning. That's my experience. So you start with a patient which already needs surgery, and moving from the bad decisions to the good decisions is what you're talking about.
Yeah. Either huge front-up cost, or it could also be that I don't need DevOps. I need that report. And then resources are not allocated to build the DevOps. I mean, it's very basic. I've seen that a couple of times, something like this. Yeah. Anything else before I move on? Yeah.
Just one quick question. I don't know if you're going to have a time, but we maybe can talk about it later. But I'm also interested in data profiling or data quality as part of the Snowflake stack.
I'll talk about it in the break with you.
Super.
Because I have also an answer for this. Or at least I have not an answer, but I have my opinion and also some tools that can help you with what you're talking about here. Yeah.
Because we are using something in Databricks, but I'm curious what is being used with Snowflake as well.
Yeah, or even a third party actually. Yeah. Anything else? Okay. 10:04. Just jump here to this one here. So what I have here is a browser interface to Snowflake. I mean, you can also use a Fig client. Some of you might know dbeaver. dbeaver, anyone? Very few. But SQL Server, Management Studio, anyone? Yeah, we all know this one. Okay, so for Snowflake, you can use dbeaver, which is an open source corresponding. It's similar to what Management Studio is for SQL Server, but they also have their own web-based UI. This is the one that I'm using now in the dark mode. So like you are on YouTube, then I am also on this one. A small introduction to this one is that you have here to the left, you have something here called worksheets. Come on. So is the Wi-Fi, I mean, I'm on the Wi-Fi here in this building, I hope this is working. I'll just try to sign out and sign in again. If I cannot sign out, then it's the Wi-Fi, then I need, okay, here it comes. So here you have, that's why we call it a demo. That's why we call it a live demo. Maybe I should grab my phone instead. Yeah, it could be that it's the Wi-Fi in this room which is overloaded. Let me try this one instead. Sorry for this. Yeah, here we go. Yeah, that's much better. So here you have the worksheets. The worksheets is similar to files in Management Studio. You have actually Streamlit built in. You have also a notebook functionality built in like Jupyter, where you can make it step by step. On the data side, you will have something which those of you who work with SQL Server would know very well. Here you see the databases. You can open a database. On that one you see schemas. If you open a schema, you see tables. Maybe not this one, because this is what I'm going to demo. This one here. Here you see the schema. Here you see, in this case, stages. In this case, some tables that could be views, store procedures. Everything that you know from SQL Server universe. So what I'm going to do now is that I'm going to show something about how to load data. So I'm clicking on this one. This is or corresponds to SQL Server where you can do something. So here I'm setting up a role that I'm using. Which role am I using currently? I'm using a DBA role for City Bike market. And then I need to use a warehouse. A warehouse is a compute cluster. So here I'll show you how you can, this was the middle one, if you remember that one. I'll show you how you can create one via the UI. I call it load. Warehouse. This is one of those compute clusters. And they come in different sizes. In this case, I take an extra small. But it could also be very, very large where I have up to 1,000 cores. So unlimited capacity in the cloud, right? So I create this one, and now I have one that I can use. So I open this one again, and then I can change the size of it. Yeah, it was created by a wrong owner. Yeah, wrong owner, sorry. Just need to have the right owner, sorry, City Bank. The right role as an owner, and then I can create it again. Let's try one more time. Then I can change it in size dynamically. Auto-suspend means that how long time should it take before it's suspended to save your cost, right? In this case, I set it to 120 seconds. Then I can show it. See, I changed it from extra small to medium. Medium is 32 cores. It took 1 second. So here you can say it has the size of medium. So you can scale it up and down as you please. Then I will actually use this one, and I will also use a schema. This command use schema means that all the table that I reference directly will be supposed to be into that schema. SQL Server, it's the default DBO if you don't do anything, but here you can actually point to which schema you're using now. Then I have this in a blob storage container. Now I can do a list command on this one. This one here you can see this add city bike. This is actually a pointer inside Snowflake that points to blob storage. So when I do this list command that you can see now, it's actually outside of Snowflake. Does it make sense? So here I see actual file name. It's JSON. It's compressed. I got many rows here. I got 845 rows, meaning 845 compressed files, which is actually each of them are JSON documents, holding a lot of writes, right? So it can be hard to get an overview of this one. So I can actually do a command like this. This is a command towards the container. It's outside Snowflake. It's not even Snowflake yet. Where I select how many do I have. I have 845. I have a total compressed storage of 2.9 gigabytes, and each file is 3.5 in average. And this is a select where I'm actually, you can see result scan last query. It's a special one. This is the result of that list one. So I'm working with the result catch directly. So you had a query, imagine you had a query in SQL Server running 2 hours, and then the result, you can actually query the result directly if you have a small change to that one. Make sense? This is the last query example. Okay, but what does it actually look like? Here I'm selecting, this is JSON. You can just, here I'm actually, this is still outside Snowflake. I'm selecting directly. And here you can see an example of it. You have a writer, date of birth, email, phone, start time, start station ID, bike ID, all kinds of information related. So this is what we actually got. So then now I'm going to create a table in Snowflake where I have this variant column. A variant column is a special kind of column in Snowflake. It's intended to host JSON documents. And why do I mention JSON? Because JSON is really popular these days. How many of you have worked with JSON? Yeah, all of you. Of course you have. Because this is what we all use. It's very agile, very flexible. You can schema evolution. You can blah, blah, blah. Many things. So this variant column is actually a column that is designed to handle JSON. And JSON will be detected intelligent inside Snowflake, meaning that you have statistics on each JSON tag. I'll show you that in a second. If you work with the databases, you know the importance of statistics like row count, like all of these things in order to have an optimal execution plan. 2 minutes, that's fine. So I'll just copy them in. I copy 1 year in now. This is JSON documents that I'm currently copying in to this table. And here we go, 104 files. And how many rows did I get? I got 6.2 million JSON documents copied in now. 6.2. Okay? And it's a medium warehouse. And then I'm selecting from these. You can see here, it's the same thing. But what happens behind the scene is that we have statistics on all of these tags. And they perform the very same, they have the same performance as an ordinary column. So now I'm changing it to a very large one. Well, yeah, 1 minute left. Now I have many more cores. Now I'm copying the rest of these ones in. We saw before there was 845 files. I took a little bit more than 100 files now. So now I'm taking the remaining 700 files in. And then I can make a select count, which comes here, which is 49 million JSON documents that have been copied in like this. And they are indexed also. So it's time's up now, but I can make a view that actually shows you how where you can actually handle this as an ordinary one, as an ordinary table, which I just did there, and now I'm selecting a sample of 1,000 rows. And here you actually have them as ordinary, but it's just a view. It's just a view, it's indexed, it's optimized like in any other table behind the scene. End of story, it's 10:15. Any questions? Okay, thank you.